Hello guys, welcome to this video. So in this video we'll be discussing about the Xchange instruction 8051. Before going into details of Xchange instruction, if you haven't gone through my playlist on 8051 architecture, you can go through it, you can save the bookmark, you can save the playlist from here, and it's accessible to you at any moment. So now coming back to the Xchange instruction. Xchange instructions are used to exchange data between source and destination operand. So in source and destination, register is always involved. It could be source or a destination. So here, these are the variations of Xchange instruction, and A is the destination, and in the source it could be a register address or an indirect address. There are two variations, Xchange and Xchange D. So first instruction, Xchange A comma RR, these exchange data bytes between register R and A. Xchange A comma address, it exchange data bytes between direct address, which is given here in the instruction, and accumulator. Xchange A at direct RB, register pointer, it exchanges the data, 8-bit data between A and the data in the address, which is given by pointer register. And this is the variation of Xchange instruction, in which it exchanges lower nibble of the data in accumulator and address in RP. So we'll look at the examples. So first example is Xchange A comma R5. So R5 is a register. So there could be any register name between R0 to R7. So it exchanges 8-bit data between register R5 and A. So let's take an example. Before execution, A is having 05, R5 is having 43. After execution, the values are swapped, exchanged between these two registers. Next example is Xchange A 0F0H. So now what's the address? You can comment it down. So obviously F0 is the address. Since this address is starting with the letter 0 is added previous to F. So F0 is the address. So it exchanges the 8-bit data between address F0 and accumulator. Let's take the values over here. A is having 05 and F0 is having 43, which is 8-bit data. Both are 8-bit data. And after execution, as you can see, the values are swapped. So now accumulator is having 43 and F0 memory location is having 05. So next instruction is Xchange A comma at direct R1. So there are only two register pointer registers, R0 or R1. Between two, any one can be used here. So in this example, it exchanges the 8-bit data between register A, which is the accumulator, and address, which is provided by R1. Okay, the data which is stored at that address, which is provided by R1. For an example here, A is 05, R1 is having 20 in it, and at 20th location 68 is stored. This is the locations of internal RAM. So this is the situation before execution, and once this instruction is executed, the output would be the data at a memory location which is provided by R1 will be swapped, will be exchanged with the data in accumulator. So at R1 there is a 20. So at 20 memory location, earlier there was a 68 stored, that 68 is exchanged with the accumulator. Now accumulator is having 68 and that memory location is having 05H. The last variation of exchange instruction is Xchange D. A comma @R0. R0 is a pointer register. It exchange lower 4 bits of accumulator register and lower nibbles of contents of address stored either in R0 or R1. Here we have to consider R0. So R0 will give us address. So at that address what data is stored, we have to consider that data. A is having 40 and at the address which is provided by R0, 95 is stored. So this is the situation before execution, and when we execute this instruction they are going to exchange a lower nibble, the lower 4 bits. So after execution we will see the result here. So earlier in memory location 95 was stored, so 5 is the lower nibble, and in the accumulator before execution 40 was stored. So 0 was the lower nibble, and that 5 and 0 are swapped, are exchanged. So now A is having 45 and the memory location which is given by the register pointer is 90. So 03 is the address of the R3 register. Again, keep in mind that indirectly R0 is providing you the address of the R3 register. R0 is used to point R3 indirectly. So notes to remember: all exchange operations are internal to 8051. There is no external access. So exchange instruction is performed along with accumulator. This is the most important point. When you are exchanging the content of accumulator and any port, the data available on the port. So what actually happens in port? There are two elements, port pins and latch. The data from the port pins is stored into accumulator and data in the accumulator is stored to the latch. So there is two different operations. So let's look at the structure of the port. So this is the port pin, this is the latch, this is the internal bus. This from this bus the data from accumulator is going to come. So when there is a exchange instructions performed between any port and the accumulator, what happens? The data from A is placed on the latch. So at the output, at Q, it shows the data from accumulator, and from the port pin data is moved to accumulator register. So not from the same point data is moved to the accumulator. Data is moved to the accumulator via port pin, and from accumulator data is placed on the port latch. This is all about the exchange instruction in 8051. Hope you like the video. If you really like the video, press the bell button, like and share the video.